So this brings us to number 9. Looking at number 9, I made a mistake before, so I had to edit that out. But let's talk about it, and we can talk about my mistake. So here's the situation. When you take a look at any kind of a problem that has a table or a chart, you really do need to make sure you pay attention to the axes. So this is the rental car cost. If you notice, the y-axis or the c-axis in this case, has a total cost for a 3-day rental. So this graph represents the total cost for 3 days of rental. So this right here, in this problem, you're asked about the C-intercept. What does it mean? And so when we think about the C-intercept, if you look, no miles have been driven when you are charged the cost of maybe, I don't know, 60 some odd dollars. Let's say 63 and some change. So this represents maybe $63 and some change. What could that represent? What does that number mean? And could it be the per day rental fee for renting the car? Just for renting the car. Let's think about that. The number of miles the renter may drive, well, that doesn't make sense because we recognize miles is across the bottom. Miles are across the bottom. The penalty a renter may pay if the daily mileage allowance is exceeded. That doesn't seem to fit if that's the initial price that you're paying before you actually drive the car. So it's really, okay, and then the total cost of a 3-day rental, assuming the car is not driven over the allowance. So both of these are really kind of the only two that make sense. And the fact that this is about the 3-day rental and this price right here is the amount that's charged before you drive, it makes sense that the answer is the last one. I thought it was the first one, so I'm admitting my mistake because I did not read carefully. All right, let's go on to number 10. So number 10, I think I started doing this already. Number 10 is asking a specific question. If the slope of the equation shown up here is 6, what is the value of c? When I think about this problem, I'm thinking, okay, y equals mx plus b. If I only had the equation in that form, I would know the slope right off the bat. So if I look at this guy and say, can I put it in that form? And yes, I can. I start off with 2/3 x plus cy is equal to 2. I'm going to use algebra to manipulate this thing. So I need to solve for y, get everything over to the other side, get y alone, get it in this form. I will do that by saying, okay, well, cy is equal to, watch me, negative 2 over 3x plus 2. I just subtracted negative 2/3 x on both sides. Now I need to get rid of this pesky c. How do I get rid of c? I will divide by c. Are you with me? So if I'm dividing by c, that means that y will be alone. This thing will actually be negative 2 over 3 with a c in the denominator, and then I'd have plus 2 over c. When I divide both sides of an equation, I need to make sure and divide each term of the equation by that value. So the c is what we're dealing with. Still, we haven't gotten our answer. Now that I have this thing set up in this way, I can see according to this equation, right, the slope is this thing here that I'm circling and or highlighting in yellow. So negative 2 over 3c is the slope. I forced it using algebra into this form. What am I going to do next? I can set this equation, or this expression rather, equal to 6 because we're told that the slope is equal to 6. And so now I can solve. How do I solve something like this? This feels really awkward, but don't feel bad. You guys know how to solve proportions, right? Proportions are just two ratios set equal to each other. So if negative 2 over 3c is equal to 6, then negative 2 over 3c is equal to 6 over 1. Cross multiply. I know, it's a lot. 18c is equal to negative 2. C is therefore, divide both sides by 18, equal to negative 2 over 18. It's equal to 1/9, negative 1/9. And I get my answer. How else could we have done this? Because I told you I'm an algebra beast and I like to do the algebra. Once I got it in this form right here, all right, I could have taken each of these answer choices and plugged it in and see which one would give me 6. Which one would make this highlighted expression give me 6, and I would have gotten the same thing. Like, check it out, if I put 4 down there, 4 would be too big. I'd get some fraction that's not going to be 6. Negative 4, same thing. Well, I mean, yeah, same thing. Basically, it would make it a fraction and not a whole number. So I'd have to put in one of these little fractions, and I want the answer to be positive because it's a positive 6. The only way to do it is put a negative fraction in there. See how we can be slick? All right, let's look at the next problem. Well, here we go. So as I'm looking at this problem, Anek has got this situation where she's competing. She's got 500-meter freestyle. She's going to accomplish that by swimming 20 times across the pool. It makes sense for me to figure out what's the length of the pool. At this point, if 20 times back and forth across the pool is going to give me 500 meters, I can figure out that the length of the pool is 25 meters. That's one length of the pool. I'm figuring out also that it takes her 26.4 seconds to do that one length of the pool. So if I have to figure out, what they're asking me is how many meters will be left, I know that we're starting with the fact that she's got 500 to do, and I'm subtracting off something. So that tells me clearly that this answer choice is not going to make sense. It's got to be one of these guys with the 500 as the beginning part. Now, how can I subtract off the distance she goes considering the number of seconds that she travels? So if she were to travel a very convenient 26.4 seconds, right? I need to make sure that she's taking off 25 meters because I know she does one length of the pool, which is 25 meters in 26.4 seconds. So I'm going to test each of these equations and see which one is going to give me that answer. If I put 26.4 into this equation, the 26.4 at the top and bottom would cancel out and I would be subtracting 25. This one seems to work. If I were to put 26.4 here, I'd be subtracting a really large number, actually larger than 500. That doesn't make sense. Similarly here, if I were to put 26.4 in there, it would not work. The answer is this one. Let's look at 12. So number 12, we are asked if the graph of this equation is shifted down 4 units, what is the x-intercept of the new line? So what we need to know is that when shifting an equation down, we're literally subtracting we're subtracting whatever value or how many places down we want it to go from the equation. So the new equation that we're talking about, I'll write it in red, is y equals 5x plus 3 minus 4, or y equals 5x minus 1. So I've shifted it down. I've taken that equation, I've dropped it. Now the next question is, what is the x-intercept? You got to remember what that is. The x-intercept is the value of x when y is 0. So the question is, in this equation, what's x when y is 0? Throw a 0 in there for y, solve your little hearts out. So you're going to throw that 1 over to the other side, 5x, and then you get that x is equal to 1 over 5 if you do that solving, and we feel pretty good about ourselves. Let's keep it moving. We've got this purchase price of this copier system. We also have this equation where, and it's really important to know what our equation is referring to, y is the value after x years. We know that the company wants to sell it after its value is now $1,000. So $1,000, and we want to know how many years that would be. So the 1,000 is going to go in there for the y. For the x value, we're actually looking for x because that's the number of years. So this is really an equation that I know you can solve. So it should look like this. 1,000 is equal to negative 1,250 x plus 850, and then 8,500, and then we solve it. And for the sake of time, I've chosen to just go ahead and solve that equation. So we get 6, and when we fill stuff in, we can put our 6 here, fill in 6, and go about our business. So we got to solve it. Let's go ahead and deal with that. So we're going to use all of our algebra knowledge to handle this. This is just a proportion we can cross multiply once we've simplified each side of the equal sign. Excuse me. So with a little bit of distributive property, we get that over here, and over here I'm going to do what's inside, which is 7 times 2, which is 14, minus 5 gives me 9. 9 times h gives me 9h. Almost ready to cross multiply, but let me simplify this first. So I have 3h plus 2 over 6 is equal to 9h over 2. Now I'm going to cross multiply. So then notice my parentheses, 2 times 3h plus 2, multiplying those two together, is equal to 6 times 9h. One common mistake people like to make is they like to think that you cross multiply when you multiply fractions. You only cross multiply when you are solving proportions, okay? Keep that in mind. And now 6 times 9 is going to give me, what's that, 54h. I'm going to subtract 6h from both sides. And when I do that, I'm left with 48h is equal to 4. With a little fancy math, h is equal to 1 over 12 because I'm dividing both sides by 48. Let's go on. All right, a problem like this is kind of hard if you're like, I have no idea how to go from here to here, right? But the thing is, you got to realize that when you are taking the SAT, these problems are answerable, and so there is something you can do. So now start going into your toolbox and start thinking, what can I do? Nice thing that you notice is that J is first and K is next, and that's the same thing here. Maybe you can do something to simplify the situation. Is there some way that you can turn this into an 8? I don't know. Is there some way that you can get rid of these fractions at least? Well, let's multiply. You know how to get rid of fractions by multiplying by the least common denominator. So we've got 3, 4, and 2. So I'm looking at this equation here, and I'm going to multiply by 12 because 3, 4, and 2 all go into 12. So when I multiply 12 times 2 over 3j, 3 goes into that, this becomes 8j. I'm loving it. When I multiply 12 times 1 over 4k, beautiful things happen. That's multiplication, by the way. 4 goes into 12 3 times. I got 3k. Look at that. My answer's just pouring right out of me. But I got to remember, what I do to one side of the equation, I got to do to the other. So I'm again multiplying this side by 12. 2 goes into 12. 6 times 5 is 30. So the answer is 30. We can talk about that more if that did not make much sense. But really the key is to realize that there's a way to get the answer, and you got to do something to manipulate that's legal, algebraically legal, to manipulate what you have into what you want. All right, next problem. Let's see what we got. If you feel uncomfortable doing the algebra and trying to do this in an abstract way, use the information that's given to you to do it in a concrete way, meaning we're asked if w is an integer less than -1. Let's think of an integer, whole number, less than 1, say -2. Let's plug it in for w. Now that we've done that, let's go ahead and solve the equation so that we can look at the slope and see what we got. So while trying to put it in slope-intercept form, y equals mx plus b, I moved my x's over here. I'm going to move my y over here. By adding y to both sides, I get a negative y is equal to negative 3x minus 3. This is not slope-intercept form because I need a positive y. Multiply everything by -1 or divide by -1, whatever is your choice, and we get y is equal to 3x plus 3. What do you notice about this equation? So now we got to think, what are some possible values? Well, clearly it's not this one because that's a negative slope. This is not this one, that's a negative slope. So it's either C or D. Which one is a positive slope? Well, they both are, but which one has a positive y-intercept? This one does. So I'm going to go with C for my answer. If you feel uncomfortable, try another value that falls within the restricted area for W. Let's go. Looking at this problem, I want you to know that you can divine what the equation of each of these lines are, A and B. And when I look at it, I can check the slope for A. The slope was up 3 over 1, which gives me 3 as the slope and 9 as the y-intercept. This slope for B is up 2 over 3, and I see that 2 is the y-intercept. So now what I have is the exact equations for each. Now what they're asking is, what value of k would I multiply this equation by to get this equation by? Well, the cool thing is, if I multiply, what can I multiply 3x by in order to get 2/3 x? I can just go through my list and figure out which one it is. What can I multiply 9 by in order to get 2? It has to be the same thing. So I go through my list and I only need to check one of these and it's going to work out. And the answer is 2/9 B, because if I multiply by 2/9, I'm going to transform this into the other equation. So part of it was making sure that you knew you had the power to figure out what the original equations were in the first place. This problem requires some slickness. Notice that we are given these 2 points, and I've identified them, and recognize that when you have an equation in ax plus by form is equal to c, you can actually rewrite it in slope-intercept form where negative a over b refers to the slope. Now that we've got that, I can figure out the slope between those 2 points, which happens to be 4/5. So the slope is 4 over 5, but according to our equation, the slope is negative a over b. We are given a value of a. We're going to plug that right into the equation. So that means that 4 over 5 is equal to negative 3 over b. I can cross multiply to answer this problem because this is just a proportion. So I get negative 15. B, if I divide both sides by 4, pardon me, over there, I'm going to see that my answer is negative 15 over 4. Organizing information is key. With the Main Street place, we've got 2 hours, 153, 5 hours, 315, and here we are just given some mysterious information about the Second Street one. 5 hours less, $10 more fixed. We need to come up with an equation given these 2 points to identify what's going on. So recognizing that given these 2 points, this is the equation of a line that goes through it. $54 is the hourly rate and the fixed rate is 45, which I can then use to get information about the Second Street line. Here's our adjusted equation. Here's where we plug in for 3 and we get the answer of 202. Equations having infinitely many solutions means that they're the same thing on both sides of the equation. Therefore, 2, after I simplify both sides, 2 is equal to a plus 1 and b is equal to negative 5. Therefore, a is equal to 1, b is equal to negative 5, a minus b is equal to 6. I would love to talk to you about this in more detail. I know I rushed through the end because I didn't want the video to end without me at least giving you all the answers and you could at least see the work. Let's talk. I look forward to seeing you guys soon. Take care.